Welcome everyone to the first video of the DP-900 Data Fundamentals Cert Prep course. This is going to be the first of about 10 to 12 videos, basically working through these slides and detailing the concepts that you need to know to be successful in your exam. Today, everyone, we're going to take about 20 to 30 minutes to just quickly go over what the exam is going to look like, the overview of this course, talk a little bit about data history, and finally conclude with some data roles. So what is this course going to look like? Well, this is an 11-week Azure course, just an 11-week course designed for you to complete the DP-900 Microsoft Azure Data Fundamentals certification. Colloquially, this is known as baby's first steps in database management. So really, this is going to be quite a review on a lot of the database concepts that we talked about throughout this fellowship. You're going to see a lot of SQL, a lot of NoSQL, and maybe some other interesting tools. This course is going to take the format of weekly readings, maybe some discussion questions that we'll discuss during the cert prep class time, maybe some quizzes, and near the end of this course, we'll take a look at some question banks that you might actually see pop up in the actual exam itself. It's about a 5-hour time commitment for this course. However, that's like a super loose approximation. I think you can get by with about 2 to 3 hours. And we're going to have 2 practice exams throughout this course just to check how your fundamentals are looking. So once again, just to reemphasize the structure of this course, on Tuesday, we're going to review everything that we saw this week. On that very same Tuesday, I'll give out the readings and all the videos that you all review throughout the week. And then by the next Tuesday, we will get back and yeah, just basically repeat the loop. Now, before we go any further, let's just talk about why. Like, what's the purpose of this certification? What's the purpose of this course? Well, first off, a certification is basically designed for employers to be able to get from a legitimate source, get information from a legitimate source that you actually know your stuff on a specific platform, such as Azure, AWS, Python, et cetera, et cetera. You can basically think of a certification as a replacement for an interview. So always consider that when you go about getting a certification, right? You always want to make sure that you are getting your cert from a pretty well-known source, such as Microsoft or such as AWS. Now, going into the details of the actual Azure course, I could just, read off this slide and tell you that this is the purpose of the course. But really, I think if we were to just summarize it, I would state that the purpose of this is to be an authority in data practices. What exactly do I mean by that? Well, and you'll have to humor me for just a second. If you ever find yourself in a job that has a very small team, or maybe their data solutions aren't set up yet, right? Maybe you're working for a nonprofit or an educational institution, and they really are not sure what they want to do exactly. You might find yourself being introduced to a tech stack, and the burden of responsibility of updating this tech stack will fall directly on you. And this image of this server with terrible wire management, pretty good approximation of what a abstract tech stack looks like. Now, I've been in this position myself, and in all honesty, I was not too well versed on my data fundamentals, and yeah, that made the job a lot harder. But after completing this course, hopefully you'll be able to use the foundation that you gained from this course to hopefully redesign this tech stack using Azure or AWS or any other coding tool of your choice into something more organized and more comprehensive. in hindsight, I should have shown this server being organized with proper wire management and so on and so forth. But really, that's the purpose of this course, for you to be an authority on tech stacks and data, specifically the Azure tech stack. So what does the exam look like? These 4 core concepts are what you are going to be tested on when it comes to the actual exam. You are going to be asked to describe core data concepts, identify considerations for relational data on Azure, and that's good old SQL. You're also going to be asked to explore or identify, considerations for non-relational database on Azure. And non-relational data, that's a little bit of a different paradigm than we were used to working with. And then finally, describe what an analytics workload looks like on Azure. We've touched on the first 2 topics in the Innovation Fellowship course, the core data concepts and relational database, but we haven't really talked about the last 2, so hopefully this will be a good way to expand your horizons in the world of data. The exam is about 60 minutes. It's designed for beginners, so there's no gotcha questions, no labs that you have to commit or complete. It's about 40 to 60 questions long, and the passing grade is exactly a 70% or a 700 out of 1,000. It's all remote. You don't have to go into any testing place or anything like that. All you have to do is log into a specific testing environment and sit there for 60 minutes or however long it takes for you to complete these multiple choice questions. Here are the sources that we are going to be using to study for the DP-900 exam. I will be posting this on Canvas shortly after posting this video. And with that, let's go ahead and talk a little bit about data history, right? How did we get here in 2024 with SQL and NoSQL and all of these concepts? What were the historical underpinnings of all of these tools that we're going to find out about, right? And by the way, if anyone has any questions about any of the previous slides that I talked about the course content or the exam itself, please feel free to reach out to me directly. So, what is the history of database management? First off, before we talk about any tools or before we talk about any events, let's just take a step back and ask ourselves, what is data, right? Take a second, pause this video, think about this to yourself. What in the world is data? Okay, now that you have an answer for yourself, I'm going to give my approximation to what data is, and hopefully it's close to what you're thinking as well. Essentially, everyone, data is raw input. Everything that you see, smell, hear, taste, etc., etc. The raw input that that goes into your person, that's data, right? Now, of course, we're talking about this from a human perspective. Data could be going through a company, could be going through an organization, an algorithm, so on and so forth, right? But really, data is just the unactioned insights, or pardon me, the unactioned information that you have yet to gain insights from. For example, let's say I'm standing on a baseball mound, and I observe the following data. There's a man in a baseball uniform on the other side. There's a small white object that's quickly approaching me, and it's getting larger and larger in my vision. And where am I? I'm standing on a pitcher's mound. All of that information, all of that sensory input, that's pure data right there, right? Now, I haven't acted upon this data yet, right? Let me go ahead and input some other data, some historical data into my brain, and let's see if some action can be gleaned from all of this. Piece of information 1, I'm a horrible catch. I've never played baseball before. Information 2, that baseball looks like it's traveling very, very fast. So therefore, the action, the insight that I'm going to glean from that is it's time for me to run sideways. Hopefully through that ridiculous example, you can kind of see the difference between data and information. I'll let you think of that, whatever you, or take from that whatever you can. Let's move forward to the actual history of data and database management. So database management honestly started sometime around the 1960s, although it could possibly be argued that the concepts that we're going to talk about today have had underpinnings or have had their start even before the 1960s. Like we're talking about World War II, 1940s, Edward Turing, so on and so forth. Anyways, in the 1960s, everyone, the term database was coined. Now, the problem was, even though we had these quote unquote databases where companies were hoping to take physical information and perhaps store it in a digital medium, like for example, information on sales, services, employees, et cetera, there was no standard, right? Developers, if you could call them that at this time, they had the responsibility of creating memory, of designing the systems that this data was going to sit on. And furthermore, the machines were expensive and super tight on memory. I know 100 megabytes doesn't sound like much today, but back then that was a sizable chunk of memory. And this resulted in machines that were error prone, slow, had poor data integrity, and worst of all, it was difficult to maintain. So to fix this, developers designed these things called intermediate layers, basically kind of like APIs between the application and the data, also known as database models, basically just logical structures that are used to explain data. There were two structures. There was the network model and there was the hierarchical model. For some reason, I always have trouble saying hierarchical. Yeah, but yeah, essentially the hierarchy model. So this seemed like a solution during the time, but there were still quite a few problems that entailed these systems. By the 1970s, developers realized that these, and maybe even immediately realized that these logical models were complex and to implement and honestly to maintain. So basically, programmers had to understand the entire structure in order to find the piece of data that they needed, right? Like, let's say, for example, we want to collect data on payments. Well, in order to get to payments, first you got to get to clients, and then you got to get to agents, right? Think about the file system path on your computer. Do you have a folder that, or a file that contains, I don't know, some like notes that you took in the class? Well, you need to figure out where that folder exists. And if that's inside of another folder, aka subfolder, you got to figure out where that folder is. So obviously, this kind of we essentially were dealing with the same problems by this point. Now, along comes Edgar F. Codd. And this is a name that I'm going to be repeating many, many times throughout this course, just because of the influence that this mathematician had on the world of computer science and data science and honestly any other technology. He published a paper in 1970 describing the first relational database model. Here were the three main components that he described. Access data via a structured query language. Do me a favor and read the first letter of that phrase, first letters of that phrase, structured query language. See what you find out. Programmers do not have to worry about physical storage. And finally, the relational database implements many kind of relationships, one-to-one relationships, many-to-one, and you don't have to worry about a hierarchy throughout this entire model. Now, I don't mean to be too dramatic, but this is probably one of the most important progressions in the world of tech. I would argue more important than LLMs, more important than Python, maybe not more important than C, the first I guess you could call it von Neumann style language, but super, super, super important. Um, Seems like an obvious idea now, but really that I would say that's the genius of it, right? It's such a great idea that it seems simple. Now, I'm going to talk about other, events in the world of database management, but once again, they all dwarf in comparison to this event that happened in the 1970s. Furthermore, I'm going to ask you to like notice a pattern that goes on as I talk about these events. Now, by the 1980s, object-oriented programming was emerging in enterprise solutions, and the problem is object-oriented programming and relational data really doesn't play nice with one another. This is called the object relational impedance mismatch. However, the solution to this is that object-oriented programming was basically implemented into SQL. And essentially, these days, SQL solutions all support objects, classes, inheritance in database schemas and query language. Essentially, it was integrated into the relational database system. Then we move on to the 2000s. So, the dot-com bubble happened, and technology was booming. Shortly after this, Facebook would arise in Amazon, and essentially databases needed to be highly scalable, available, and flexible. What does that mean? Well, think about it this way. Have you ever had a object in your Amazon shopping cart and you just kind of kept it there, and then you never ended up buying it, and then you ended up deleting it? Well, think about what that's going to look like in a relational database, right? What do you do with that object? So you insert it there, and then it's expected that you immediately remove it. And what if the attributes of this object look different from another object, right? All different problems, all various problems that are going to be arising as technology becomes more apparent in these systems. Now, originally, the idea of NoSQL was to replace SQL, and we'll talk about the difference between relational and non-relational database later. But essentially, what eventually happened is that NoSQL solutions eventually adopted the ideas of SQL. In fact, I think we could say that SQL was integrated into, or vice versa, NoSQL was integrated into relational database systems. So essentially, everyone, I hope you all noticed the pattern. A problem arises, SQL kind of meets the problem head on, and so on and so forth. And now, at this point, we're in the era of specialized database systems. We have databases that are optimized for joins, such as graph databases. We have time series databases. Maybe we'll talk about a few interesting solutions during this course, and also during the class time. But yeah, that's essentially going to be, well, actually, pardon me, I messed up. I hit the end button. Anyways, we're not done yet. My apologies. Just 5 more minutes. So anyways, here are some discussion questions for you to consider. It's not necessary for you to complete these strictly, since they're not really going to show up in the Azure exam itself, but these are just good motivating questions for you to continue your development as a data authority. And I'll post these on Canvas. And we'll talk about that later during class. And here's the source that I was using. I'll probably post this on Canvas as well for you to reference, just to make sure that I'm not making these things up, right? Okay, now that we've talked about the history of database management, and hopefully you get an idea of like the development and the time and research that it took to get us to this point, let's go back to the 21st century, and let's just talk about the data roles. And this is something that Azure will ask you during the DP-900 exam. So what are going to be the data roles that we are going to discuss in this track, in this course, rather? Well, it's going to be a database administrator, a data engineer, and a data analyst. I want to emphasize that these are data roles, not necessarily positions, although often when you go on Indeed.com and you type in data analyst, you'll see hundreds of different positions popping up called data analyst. But in more abstract terms, really these are just the responsibilities of a job. Sometimes a data engineer will be asked to do the responsibilities of a data administrator, and maybe sometimes a data analyst will be asked to do the responsibilities of a data engineer. Hence, these are roles. Now, in Azure, there are more specialized certifications that you can take to prepare for these specific roles. But for now, we're just going to take a very, very general overview of what these roles are. And later on, we'll find out how they relate to Azure. So first off, you have the database administrator. This is the person that's going to be responsible for the availability of the database, the user permissions, who's using the permission or who's using the database and how are they using it. And finally, the operational aspects, right? How often does this database update? How large is this database? How much RAM does this database use? So on and so forth. When we say availability, we're just basically talking about the uptime of the database, right? Companies often say, oh, 99.9% availability, so on and so forth. In very, very, very rare instances do we expect our database to fail. In all optimistic terms, right? So just to summarize this, a database administrator manages databases, assigns permissions to users, and finally handles the backups of data and also hopefully restores the database in the event of an emergency or a failure, rather. I don't know if you all remember this, but back in 2023 or 2023, the FAA grounded all flights for the first time since September 11th, 2001, due to a database error. So this position or role is very, very, very critical, depending on the domain that we're working with, right? If you don't have your database running, well, you basically can't do any of your operations. If Amazon doesn't have its database running, no purchases or sales are going to be performed. All right, next up, everyone, we have the data engineer. Think of this as the person that just designs the ETL pipelines and also manages the processes for data integration across the organization. And this is a very real problem that all organizations experience, especially if they don't have a database platform currently. Maybe one team keeps its data on Google Drive, another team keeps its data in a file cabinet. Well, a data engineer would hopefully set up the infrastructure to allow everyone to be on the same platform and share data safely. And once again, like I said, they design the ETL pipelines and the data cleaning routines. They identify data governance rules, right? Where should this data not be? Who should we not transfer this data to? And once again, ETL pipelines. All right. And finally, everyone, we have the data analyst. I know it seems like the data analyst has the least possible responsibilities, but this is the most statistically minded role, right? This is the role that entails making visualizations and charts and dashboards that allow various people in the organization to make informed decisions, right? Here's how we performed Q2, and if we keep this up, here's how we will perform Q3, right? And then based off those insights, hopefully people will be able to make decisions. All right, and here's some other review questions. Once again, somewhat ridiculous. I'll put them on on Canvas for you to consider and answer. We'll also probably talk about this during class as well. Once again, here are the sources that I've used. We'll post these on Canvas. And yeah, that's pretty much it for this week. Don't mind this term from last week. All these readings will be posted for the first time on Canvas today. And next week, everyone, we will actually talk about Azure data services, formats, and file storage. In fact, I'm probably going to record this video immediately after this video, post it on YouTube, And yeah, I'll also make it available for you to review as well. But yeah, that's basically going to be it. See you all later.